In this example, we will find up to 3 integers that can be used to replace k so each trinomial can be factored. In part A, we'll find values of k for 3x squared plus kx minus 10. We need two numbers that multiply to minus 30 and add to k. In the context of this question, think of k as a placeholder. We are looking for integers that could replace k to make the trinomial factorable. It's actually pretty easy. Start with a table just like the ones we've been using all along in trinomial factoring. We need to find two numbers that multiply to minus 30. Let's try minus 30 and 1. These numbers have a sum of minus 29, so minus 29 is a potential value for k. Next we'll try 30 and minus 1. These numbers have a sum of 29. This is another potential value for k. Now we'll try minus 15 and 2. These numbers have a sum of minus 13. Three potential values for k are minus 29, 29, and minus 13. We could have kept going to find even more k values, but the question specifies that we just need up to 3. So we now know that 3x squared minus 29x minus 10, 3x squared plus 29x minus 10, and 3x squared minus 13x minus 10 are all factorable expressions. In part B, we'll find values of k for x squared plus 4x plus k. First of all, we need two numbers that add to 4 since b is 4. The two numbers have a product equal to AC. Since a equals 1 and c equals k, we can write 1k equals product. Create a table. We need a product of 1k and a sum of 4. We'll approach this table a little differently than other tables we've seen. We'll find two numbers that add to 4 and put them in the B column. First we'll try 1 and 3 since these numbers have a sum of 4. The product of 1 and 3 is 3. Divide both sides by 1 to get k by itself. Our first potential value for k is 3. Next we'll try 2 and 2 since these numbers also have a sum of 4. We then get 1k equals 4. Dividing both sides by 1 gives k equals 4. Now we'll try 5 and minus 1, another pair of integers with a sum of 4. We get 1k equals minus 5. Divide both sides by 1 to get k equals minus 5. Three possible values for k are 3, 4, and minus 5. We could have gotten more, but the question says we just need up to 3. This means that x squared plus 4x plus 3, x squared plus 4x plus 4, and x squared plus 4x minus 5 are all factorable. In part C, we'll find values of k that make 3x squared minus 8x plus k factorable. We need two numbers that add to minus 8 since b is minus 8. The two numbers have a product equal to AC. Since a equals 3 and c equals k, we can write 3k equals product. Create a table to record our work. First, we'll find two numbers that add to minus 8. Let's try 3 and minus 11 since they have a sum of minus 8. The product of 3 and minus 11 is minus 33. Divide both sides by 3 to get k by itself. Our first k value is minus 11. Next, we'll try minus 5 and minus 3. The product of minus 5 and minus 3 is 15. Divide both sides by 3 to get k equals 5. Now try minus 10 and 2. The product of minus 10 and 2 is minus 20. This won't work since minus 20 divided by 3 is a decimal number. Now try minus 2 and minus 6. These numbers have a product of 12. Divide both sides by 3 to get k equals 4. Three possible values for k are minus 11, 5, and 4. This means that 3x squared minus 8x minus 11, 3x squared minus 8x plus 5, and 3x squared minus 8x plus 4 are all factorable.